Thank you for having reminded me. So we were talking about one slightly more complicated scenario with respect to yesterday. Yesterday we had 3 scenarios. Calling the square root function, which is very simple, one argument, one result with basic built-in types. A second scenario, extracting the field from an object. There are no side effects, but there is serialization involved because we are communicating with a custom object defined by our own code. Third scenario, we merge the complexity of serialization with the complexity of side effecting objects, and we modify the state of an object on the server side. So in order to prove that we need to return modified objects if we want to program in a distributed fashion. So side effects are not allowed. There is also one more complication. Look, I define a subclass of person whose name is a woman that represents a subset of person, and woman have, for example, an extra information. For example, what is something that only women do have that men do not have? For example, it is just for fun. How would you say makeup? So we have a list inside the woman. We have a list of items. Because a woman has a lot of objects, no? Of course, I'm just joking, but it is just an example. And I create a class item in this package. No, wrong. What is an item? An item is, for example, an item, it could be something like that. Or what is the English name for Rossetto? Do you know that? You know the English name for Rossetto? You don't.
Lipstick.
Lipstick. I forgot about that. Okay. Okay. So we have of course it is just a toy example. I don't want to complicate this any further. So we have a list of items, and we can add an item of type item to the list. Makeup, lipstick. Let's imagine a third object. Borsetta. It is a very simple example. I don't want to create more objects, more classes, more complicated than this. I just create a woman subclass that has an extra field within it, and this field is a list of items. Items are either makeup, lipstick, or handbag. Good. So what happens if I do this? Let's create a person with a woman name. And here I add, for example, sorry, I can't use the other one, okay. Item handbag, and then lipstick. Okay, I populate the object, and then I do this. That is, I am invoking the make holder. Let me see. Yes, sure, you're right. Look, I invoke the makeholder method, which is a method exported on the interface, which is the method that we use it for making the first person holder. And I want to use the same method with the second person. The second person is an object of type woman. So makeholder is a method that picks a person and returns a person, right? So I can pass an object of type woman as argument for the parameter of type person, of course, because there is some typing here. So I can pass a woman as a person. The problem is that the client doesn't know the woman class, because the woman class is here. Sorry, the server, not the client. I said it wrong. The server side doesn't know anything about the woman subclass. It is the woman subclass has been defined on the client side only, and there is no mention of the subclass in the server code. So, in order to make this work, it is necessary that polymorphism applies to the server side. Let's make a simple test. Also, there is also another problem. The modified object with the new age increased by 10 in this example is returned as an object of type person, not as an object type woman. So if I want to replace the original, I need to cast it, because there is no way for knowing at compile time what is the type of the original argument, unless I change this signature in this way. In this way, I modified the signature in such a way that the argument is not necessarily a person. It is an argument of type P, where P is a generic type. P has a constraint, it must extend person, and the same P I pick as argument is returned. So the benefits of this signature is parametric polymorphism, basically. Is everybody okay with this language quirk? Do you understand what I did? I comment the original, I go on the server side, and here I need to implement the new signature. And in order to implement the new signature, how am I supposed to do this? I can't do this. I can create a new object whose type is unknown. So I need to rely on the side effects. And this is a typical scenario in distributed applications. Because when you write a real program, a real world program, a big program, in a distributed fashion, you often pass objects whose type is a subtype of what the server has. So basically, we need to modify the original and return the original. Otherwise, we are unable to construct an object of the correct type, because we can't say return new P, because you cannot use constructor in a polymorphic way. Constructors are only monomorphic in every language. What applies to Java applies to any language with the same sort of feature, basically C#, C++, even Python is like this. Then let me compile. Okay, I compiled. And now I want to run the server again. Okay. The client. Here you go. Look, it says exception in thread main, null pointer exception. When invocating add, the add method. Let's have a look. Line 19, 19, yes. Yes, no, this is my fault. It's not your fault. I forgot to create the actual list. Okay, here you go. And this is the printing, because probably I printed the wrong one. Yes, now we got it right. Okay. Now this is the printing of the second person, who is a woman, and it is a subtype of person. And the original age that we set up was 50, and it prints 50 even if I added it. Why? Because I am binding the result to a different variable and I'm printing the original. What happens if I do like this? Can I do that, or even this? Yes, I can. Thanks to generics. And let's see, in this case, what happens. I don't even need to run the server again. Here is the difference. See the difference? Age 60. So with this technique, we proved that RMI is consistent with objects that the server side doesn't even know exist. Probably you are not very surprised, because you are not fully getting the power of this thing. You are probably witnessing the thing I'm showing you. You might think, well, it's normal. He just modified the object. It is not normal at all, because I am creating an object that the server doesn't know. The woman class is defined inside my class. The server class doesn't know anything about the woman class. And at the same time, the server has a polymorphic implementation with a side effect, and the client simply benefits of this polymorphic implementation using an object whose real type is unknown to the server, and the thing works anyway. There is one final thing that we could try. Let's see if you got it. What is the last thing that we could test in this scenario for stressing the RMI system? Do you have any idea? Look, I give you a hint. The makeholder method uses two methods from the person object: the set age and the get age. What happens if the subclass, that is woman in our example, what happens if the subclass overrides those two? Does it work anyway? I mean, if the server doesn't know about the woman class, And if the woman classes, which is defined only on the client side, redefines one of its methods, how does the server behave with this respect? How can he invoke the correct implementation of the method even if he doesn't have the code? Let's make a test. So I redefine the getAge method on the woman. No, sorry, -1. Because when you ask a woman what is her age, a woman always lower it down, no? So a woman responds to the question, what is your age, with the getAge method, decreasing the actual age in the field, stored in the age field. Of course, this is a funny scenario, but in order to make you understand what is overriding in a remote method invocation context. So what I expect here is that executing the makeholder method on the server dispatches this version of the getAge method, and so Maria Callas shouldn't have 50 years, and so it is not increased by 10, but he declares to have 49 years according to that method. And then the setter will set its age, and it will increase its age by 10, which makes 59 and not 60, like in the last code. Let's see if it works. Compile. I'm not even relaunching the server. I only relaunch the client. Boom. Let's see what happened. Okay, server exception, remote exception occurring the server thread. The next exception is unmarshalling exception, error unmarshalling arguments. What's going on here? What's going on here is that the server side doesn't know the implementation of the overridden method. Look. Again. This works. And this doesn't. Weird, no? So basically, as soon as I perform an override on any method of the class that the server knows, then the serialization is broken. This is a very important topic, because when you program, sorry, sometimes I forget to put on top my work. This is a very important point, because when you program in a distributed fashion with an object-oriented language, and it doesn't have to be Java only, it could be any other language. Even Python is an object-oriented language. It has objects, and you often write data structures that are classes. It happens. So in any scenario where you fully take advantage of the basic paradigm of object orientation that is overriding, that you can't use it. You can't. Because the server needs otherwise to load dynamically the implementation of the overridden methods of the subclass that it doesn't know. It is a very complicated point, and actually, it is something that has no solution, because how would you do that? I mean, if the server doesn't know the code, what would you do? It means that the client would need to send the compiled code of each subclass it defines to the server, which is something very complicated. So the server needs to load classes at runtime, not only at compile time, at runtime, in order to have the dispatch table of the overridden methods of any potentially overridden method coming from the client. My goal is not to make you a programmer for Java MI. My goal is to show you the complications and the technological challenges of a remote invocation system. Java is a very easy to understand one, but the same concepts apply to other systems. So the point of that we have seen today, that is, when the server doesn't have the actual implementation of the subclass, it is broken. This concept holds for any remote invocation system. There is also another complication, security complications. As we saw yesterday with Alberto and the small test that we did together, that the test didn't work, if you remember, we have an additional complication, security. Am I allowed to connect to the given port? Am I allowed to truly raise a process on the server side? There are security problems involved with remote invocation. So guys, basically, what I'm going to make you understand is that this is a complicated thing, and it has a lot to do with networking, synchronization, and security. Now, we're gonna have a look at some different details that we still haven't talked about. Complex serialization. What is serialization? Serialization is a fundamental ingredient of a remote invocation and distributed computing. Because, as I already told you, when you communicate through a channel over the network, you have to serialize objects. In order to serialize objects, you need to transform them into strings, basically. In Java, we are lucky because we just need to put this implement serializable thing on a class in order to make the compiler generate our serializers. But what happens if in your class you have pointers and references to objects that cannot be serialized? What does it mean to have objects that cannot be serialized? You might believe that any object could be serialized, but in fact it isn't. Let's make an example. A socket object. What is a socket? A socket is an entity that in most operating systems is equivalent to a file descriptor from a kernel point of view. And a socket is an entity, an object, that basically provides two methods, one for reading and one for writing, strings of bytes or characters. So a socket is simply a stream. It is like a pipe or a file from an API point of view. When you program over the socket as if you would program over a file or over a pipe. There is a degree of polymorphism at the system level, at the kernel level. But what is a socket really from a data type and data structure point of view? Do you have an idea of what a socket is? What if I put a field of type socket inside of my classes, and I try to serialize my classes with a field of type socket inside them, or another example, a field of type file inside them? What does happen, in your opinion? Do you have a theory or an hypothesis? Does anyone want to tell me?
Probably an object of type file is not serializable. So,
but is it truly not serializable, or it is serializable, but serializing it doesn't have any meaning?
it
What is
doesn't
the
have any.
difference?
It doesn't have any meaning because it's
Why?
a path. In this case, for example, for a file object, it's related to the
To the
is
machine where the file is at. Let's make an example, Alberto. If I put a field of type file inside my person, now don't think this has any meaning. It is just an example. Just an example. It doesn't have any reason. There is no reason to put a file inside a person, of course. But I'm just telling you an example. If you put a file field inside your class that you're going to serialize, the language won't tell you that this is impossible. Why? Because the file class within itself holds one simple information, the file descriptor of the file. And what is a file descriptor? An integer. So file descriptor are integers in most operating systems, in Windows, in Linux, in Mac OS X, of course, because it is a Unix. And so in most operating systems, files are actually integers. They are just numbers uniquely identifying the file on the hostile file system, just that. And so the file class has a field inside it, which is a field of type integer. And so serialization is straightforward. I'm simply serializing the file descriptor. But when the server gets the file descriptor on the other side, the file descriptor means nothing. There is no file in the server because the file might even not exist, or even if it's not a file and it's just a socket, the file descriptor is always an integer, and that integer doesn't have any meaning in the scope, in the context of the server process. You see what I mean? So serialization is something that you can technically do anyway, because what you serialize are just fields of classes, and fields have a type, and these types at some point must reduce to basic types, because even if you serialize a class that has a lot of fields whose type are objects, then these objects might have other objects. It's a tree of references, but the leaves of the trees must be, of course, basic built-in types. So the leaves of any of these trees are actually integers, doubles, and characters. So anything is serializable from a technical point of view. Anything reduces to basic types. So in the end, you can have a recursive serialization algorithm that simply recurs in fields, and it serializes recursively all the references of any class. In the end, it will serialize numbers, strings, characters, and stuff like that. So anything is serializable. The problem is that not everything means something in the other context. This is the problem. In order to understand this kind of problems, you have to raise your knowledge of computer science. I mean, there is no book that explains these things. There is no website that explains these things. There is no tutorial or document that provides you with a list of what has a meaning if you serialize it and what doesn't. In order to understand, you have to raise your education in computer science. You have to know that a file is not a file, it's just a number for the operating system. You have to know that a socket is nothing. A socket is just a file descriptor in the operating system. And if you serialize it, it means nothing for the other computer. So you have to be aware of how operating systems and technology works and how informatics works. This is my personal suggestion. This kind of knowledge is not something that you can acquire from studying, is a kind of knowledge that you can acquire from yourself after having studied many other things. Let me now show you some alternatives for serialization. Serialization is something that in Java is performed automatically, as I told you, but it is not the only language that exists. In other languages, for example in C++, serialization is not performed automatically. And so, how are you supposed to serialize stuff in other languages? Or even, you could make a program, a distributed application, that invokes remote procedures or remote methods, and the client is written in Java and the server is written in C++. So what happens if we want to make two different languages or two different technologies or two different frameworks communicate in a distributed computing model? Imagine that we have our client written in Java and our server written in C++. How can this work? In order to make it work, we need to change our serialization mechanism. The underlying serialization mechanism depends on how the language and not really the language, the standard library of the language deals with serialization. In Java, serialization is performed in form of strings, in very compact strings. In C++, there are different libraries for serialization. In Python, serialization is performed through strings, but are they the same strings that Java uses? Of course not. Of course not. Because every technology is different. You know that the world is like this, no? It's nothing new. Every language has its own way of serializing. Even if it uses strings, the format might be different. The way the algorithm of serialization might be different, and the way it puts separators or brackets within the serialized string might be different. So it doesn't mean that since we have a string serializer in Java and we have another string serializer in Python, they can work together. Absolutely not. They will surely not work together. So when we need to make two different platforms communicate and invoke objects and methods remotely, then we need to define a common field for serialization. That is a serialization format that is common to both, even if they're written in different languages. There exist some proposals on the web. For example, one way for universal serialization, that is it is portable to different languages and platforms, is XML. XML, as you already know, is a very simple tagging nested language for defining nested data structures. Your XML actually is a meta language, not a language, because with XML you can define the format of formats. So in XML you can absolutely define your own DTD or schema for representing recursive data types. to be serialized. Let's make an example. If we want to serialize a person in an XML way, we can do like this. I'm just using Java for writing the code in order to make you understand what I'm doing. But the same has to be written also on the other language on the other side. Suppose we have a server in Java and a client in C++ or whatever. You need to implement the serializer in both sides. Or if you don't want to implement it, you have to use a library that is being ported to both languages, and you use the library. Here, I'm gonna give you a simple implementation in order to make you understand how XML serialization works. For example, we could produce an XML like this. And then we close. Do you understand what I'm doing? And inside here, we must put the tags for the fields, no? Let me remove this. So, for example, here we could have, for example, field. Are you following me? Do you understand what I'm doing? I am creating an XML on the fly to show you how, with your logic, you can transform any class with its field into a series of tags in XML. This class, the person class, might be represented by a root tag. Well, let's do this. Okay, just name. Root tag with the name of the class, and then inside this tag we have any number of sub tags that describe the format of the fields, and for each field we have a field tag with the name of the field, the value of the field, and the value must be put programmatically from the code. And then let me see if I can do something like this. I should be able to. Oh, perfect. Perfect. I guess that you already know how XML works, no? You already know XML?
Yes, from your course of Android software engineering.
You have never seen XML otherwise? Well, it's very easy. Does anyone need to understand XML? Tell me. I show you basically on the internet something quite easy to understand. This is XML. No, this is no example.
Yes, Professor. I think that more or less everybody knows.
Everybody knows, no? It is just we open tags and we close tags and we can nest the thing inside. In XML, you can invent your own tag names. I'm inventing at the moment. root is a name that I just plain invented right now. Field and this stuff is something that I plain invented right now. Just be careful with the escaping rules of strings. And then we have also the address and the value. And then we have age and the value. We could add another, in my opinion, I would add another information for each field, the name, the type, the value. And then in the end, I apply the first argument as name, surname, age. So what does this do? This method simply transforms all the information that are relevant for a person, object, into an XML series of tags, simply. And I invented the format. What if I had, for example, a recursion inside the class? For example, if within the person class, I had a field of type person. In this case, I need to define an XML that supports recursion. And so it must support nesting of data structures in a deliberate way. It is not easy. It needs a lot of clean thinking and somehow wisdom. You need wisdom in order to do this. Because you need to understand what is the relevant information of an object. If, for example, I had imagine a file like before. In this case, for example, instead of serializing the file class itself, I might find a different trick, a different solution. I might, for example, just serialize the name of the file instead of serializing the file descriptor that has no meaning for the server. So custom serialization is something that is quite needed in big applications because some fields, some information do not simply serialize normally, and you have to write your own custom format. There are libraries, for example, Redstone, that is a common, cross-language, cross-platform library for serialization in XML of generic data structures coming from different languages. And there is an API for C, for C++, for Java, even for C#, for anything. And in here, you can see an example of serialization. Let me show you. Here, you serialized, I'm not sure if you can see it. This is the XML generated, and this is the code that generated them. See the output? It serialized hello and a number, and the format, the XML format used for serialization is totally different from the format that I invented a few minutes ago. Totally different, because there are many different ways of doing this, and a library like Redstone that must support many languages, many data types, recursive data types, and other stuff. They invented a complicated format that supports most available scenarios. You see? So it is not an easy task to perform serialization in the correct way, even if you use a library. This is another way of serializing using JSON. You know what JSON is, guys?
Yes.
What is
Yes.
JSON? What is JSON?
JavaScript object. JavaScript object notation. If I'm
No,
not
I
wrong.
don't want the meaning of the name. I want the definition.
It's
Imagine that I knew nothing about computers. Tell me, explain to me what is JSON.
yeah, as Matt has answered in the chat correctly, I think also. Please, Professor, we have some participants that cannot use the microphone. So sometimes they are only good. They are only written.
Yes. As Matt has said, nested key value pairs format. Exactly, as Matt. Exactly. JSON has nothing to do with JavaScript or Java. JSON is a meta language whose meta syntax is in, as you said, key value pairs, and it is a meta language that it is not only similar to init files, for example. Do you know init files, Esmat? Init files are files where you put key values, strings, bindings. JSON is more than this. In JSON, you can also nest structures. And so you can, in JSON, you can say, okay, I have a records of key value pairs, and some value is a sub-record or a sub-list of records. And so it is a meta syntax for describing nested data structures and data types using a very simple key value pair notation. By the way, do you prefer XML or JSON? From your point of view, if I want to ask your personal opinion, do you prefer JSON or XML? They are equivalent, they do the same thing. They represent nested data types. So the goal is the same, but the syntax is different. What do you prefer? JSON. Why, Esmat? Why do you prefer JSON? Let's see if you have the same opinion that I do have. Why do you prefer that? Write it. Riccardo, what do you mean for easier to use? What is easier to use?
For me, in a usual data science task, it's easier to find a data set that is in a JSON format instead of XML format.
Okay, but this is not very interesting as an answer. I mean,
yeah,
I asked what you prefer, not because you are it simplifies your work when you find data sets. I mean, give me your opinion from a meta language point of view. Bocalone says, I prefer JavaScript with more straightforward. Esmat, frameworks and languages have tools for generating both XML and JSON. There is no true need to prefer one over the other from a tools and the language support point of view. The real thing is what Lorenzo said, because it is more readable. JSON is readable. I mean, when you have 7,000 trees nested one each other, try to read an XML and try to read a JSON. You can still read a JSON because the parentheses are clear and the syntax is very brief. But if you try to read with your eyes an XML, it is almost like reading binary format, almost. Because XML, even if it is human readable in theory, it has such a syntactic overhead with all those tags that must be open and close, open and close, open and close, that the text in the end becomes unreadable by humans. And it is equivalent to having a binary format, which is basically unreadable anyway. So the most important benefit of JSON is readability for humans. So JSON, there are libraries that allow serialization in JSON format. How would you serialize the same object in JSON format? Simply like this. I'm implementing, of course, my own methods for serialization, but of course they are just an example. I already told you. If I wanted to use a library, I wouldn't need to write this method. I just import the library and use the serializer provided by the library. The reason why I am implementing this method is in order to make you understand how translation from the object to the syntax of JSON or XML work. In JSON, I would do something like this. The binder separator is a column and not equal in JSON. Are you okay with the escaping of? Are you okay with the escaping of quote characters? Are you okay with that? Here is how a JSON, very simple JSON serializer would look like. And it is much more readable than XML, even at this very simple level. Let alone what happens if you want to serialize a complex tree of objects in XML. You cannot understand a thing. And so why is it important to understand the serialization, and why is it important to understand also another big topic of this small course that I am providing to you? That the other big topic is side effects versus non-side effects we have been talking about yesterday. So we have two major ingredients: serialization, which is a problem on its own, and another big problem is side effects in computations when you require remote calls. These two topics, serialization and side effects, are the most important topics in any technology. And what if I tell you the name AWS? What do you know what it is? AWS? Does it ring any bell in your mind? Amazon
Web Services.
Exactly. And what is AWS? AWS is a REST-like full. It's not really REST, but it is even more extreme than RESTful APIs. It is a stateless, functional, pure web-based API approach for performing distributed computations. And so now, in order for you to understand the AWS, or for example, AWS Lambda that you might already have heard of, let me show you. I had open. No, it's not. Where did they put it? Lambda. Have you ever heard about Lambda? The technology, Lambda technology? Ever heard?
No.
AWS Lambda, you see my desktop, is the technology underlying AWS. So AWS is the overall name of the service that Amazon provides. And AWS Lambda is the name of the platform technology. what does Lambda seem to recall to you? Lambda, does it recall something to you, the term Lambda?
Lambda expressions.
And where do they come from? From Lambda? Calculus.
Expressions.
The name comes from Lambda calculus.
Okay.
And Lambda calculus is a form of mathematics described for used for describing the semantics of and the syntax of functional programming languages. So what is a lambda? A lambda is an anonymous function in our language. In nowadays, lambdas are very widespread also in imperative languages. For example, Java has lambdas nowadays. Even Python has lambdas. The latest version of C++, the C++ 11 standard, introduces lambdas into C++. So lambdas are a feature of functional languages created in the 70s and in the 80s, and in the first functional languages. And then in 40 years, more or less, almost all imperative languages introduced lambdas as well, because lambdas are very useful for expressing anonymous functions. And why Amazon is calling AWS Lambda its own service? Because Amazon created a stateless, pure, functional-like service. As I already told you, probably, if not in this course, in other courses of mine, the overall the world of programming is slowly going in the direction of functional programming. This is a phenomenon that started more or less 10 years ago, that all mainstream languages that are not functional, for example, C, C++, and Java, started to introduce functional features. That is, features coming from the functional world. For example, lambdas, pattern matching, type inference, and whatever. And so the overall world of programming is slowly converging to functional programming. Why? Even Amazon, who is a leader in mainstream web service deployment, they even named their main technology platform with the name Lambda, which is a name that until 10 years ago no one did know. If you ask someone that got graduated in computer science 10 years ago, and he's not doesn't have much knowledge of languages, he doesn't even know the word Lambda, because the word Lambda has become mainstream very, very recently in the last year. So mainstream that even Amazon uses the word Lambda. And why? Because the functional approach, that is the stateless approach, without side effects, without modifying, without assignment, basically, is the correct approach for almost anything, even for web services. I tell you a small story, just 2 minutes. Do you know anything about quantum computing? For sure you have heard about that, no? Quantum computing is the upcoming revolution. Actually, it is not going to happen very soon. It is a revolution that will take probably half a century to take place. But anyway, in these decades, we will see a constant progressing towards quantum computing. Quantum computers are very hard to understand and very hard to program. You can be the best programmer in the world, and you can have a 40 years experience in programming, and still you might not understand a single line of a quantum program, because quantum computing has a totally different programming paradigm with respect to the Turing machine, because every language that we use, every computer that we have is a Turing machine, basically. So we program computers always in the same way. That is, we have a memory, we can modify the memory, we can read the memory, write the memory, and make arithmetic computations on the memory. This is the basic programming paradigm of the whole world. Then there are different languages that implement this paradigm in a different way, but the basic ingredients are the same. You can modify stuff and you can perform arithmetic computations. Well, in quantum programs, you do not perform arithmetic computation, and most of all, you can't modify stuff. Why? Because at the lower level of reality, our universe, that is the reality we are in, at the small scales, that is the quantum scale, where there are particles, atoms, photons, electrons, at the small scale, there is no way to create or destroy anything. And this is also a physical principle, if you know about that. And therefore, you cannot truly modify any state of any particle without preserving information. Think of this. When you write, look at this. When you create an integer variable and you put a 3 inside, and then the next line you put a 5, that 5 completely overrides the 3, and there is the information of the 3 is totally lost. We are very used to this kind of programming. We are used to assign the data to variables and totally lose the previous content of the variables. Well, this cannot be done at the quantum level. Why? Because the state of particles cannot be lost. And so you cannot simply say that if something had a state A, afterwards it has a state B that is totally different. You can't. You can only transform A into another state. This is something very subtle for us to understand. But what is the important thing behind this? The important thing is that assignment and the side effects cannot be translated into quantum computing. So the future of computing is not imperative. You see the power of this. Can you see the power of this thing? Well, I'm saying that the future of the overall computing, when everything will become quantum, we will lose the ability to modify data in the same way we were used to. And so the future of computing is functional, not imperative. Why do I say that it's functional? Because functional languages already has this feature. You can't assign. You can only transform that in other data. And so we discovered that our reality, our universe, actually works like functional languages and not like the Turing machine. So our future is stateless. And this is a reason why also Amazon created this stateless paradigm for programming web services. Because perhaps in 30 years, they will implement the quantum computers that will compute such web services. And they will be able to, because there are no side effects. So the next lesson, we will talk about AWS Lambda technology, which is nowadays the standard technology for web services. The world is going functional, and the world is going quantum, and the two things will merge one day because they are compatible with each other. When you will see the API for writing an AWS Lambda function, you will understand that you can only write functions that perform computation over their arguments, and they can simply return a result. They cannot modify the arguments, so they don't have a state. They are not stateful, which means stateless. And this is a programming paradigm. When you program, you are often not used to avoid side effects. In order to program AWS, you need to change your way of programming. you need to change your way of thinking algorithms. You need to change the way that you express algorithms. You need to reformulate your mind and translate all of your ideas instead of sequences of operation in terms of expressions that compute something. And this is a major leap for a program. The last 5 minutes are for questions. You have anything to ask me? No questions? If you have no questions or nothing to ask me, we turn off. Are we going to talk about function transfer? What do you mean by function transfer, Lorenzo? What do you mean exactly? Excuse me. What is the difference between passing an object and passing the code? What is the code? What do you mean? I didn't understand exactly. You mean, no, I'm not going to talk about that. If you are interested, I can. You mean on the server side, if you don't have the code, you have to download it. You mean that? It is a very complicated thing, and some frameworks, for example, Corba, do that. But for example, RMI don't. It is a very complicated thing. Perhaps tomorrow we will speak a little about that. Any other question? If there are no other questions, we stop here. Thank you, guys. See you next time. The next lesson will be the last lesson and will be on Wednesday, 1st of April. Goodbye.
Bye.